Now there's an easier way we can create generators, providing the generator is simple. We're able to use what are known as generator expressions in order to do this. So similar to the lambda functions which create anonymous functions in a single line, generator expressions can create anonymous generator functions. And the syntax for generator expressions is similar to that of a list comprehension in Python, but the square brackets are simply replaced with round parentheses. Now the major difference between a list comprehension and a generator expression is that a list comprehension produces the entire list, while the generator expression produces one item at a time, as I'm sure you've guessed. Generator expressions also have what is known as lazy execution, and that essentially means it produces items only when they're asked for. And for this reason, a generator expression is much more memory efficient than an equivalent list comprehension, as a list comprehension would store the values in memory. But a generator expression will only yield a result when the caller has asked it to. So to demonstrate this, I'll first of all create a list called my_list, and we'll set this equal to a list of integers 1, 2, 3, 4, and 5. Now, if I wanted to create a list of values which doubled each element in this list, I could utilize list comprehension as follows. So we'll store the result in a variable called list_comp, and we'll set this equal to square brackets, and then we will put I, which will represent each element in this list, multiplied by 2 for I in my_list. Hopefully this syntax looks familiar, as we covered it earlier in the course. If I now take a look what's stored in list_comp, we get a list of integers 2, 4, 6, 8, and 10, which is our original list doubled. Now the same thing can be done using a generator expression. So if I create a variable called gen_exp for expression and set this equal to round parentheses and then inside put I multiplied by 2 for I in my_list, so exactly the same syntax as our list comprehension, with the only difference being the brackets that we're using either side, you can see that when I now take a look to see what's stored in gen_exp, we have a generator object at this location in memory. And what can we do with generator objects? Well, we can loop through them and call upon the next element accordingly. So if I print out the result of calling the built-in next function and then pass in our generator object, so gen_exp, you can see that we get 2 printed to the screen, which is that first element doubled. If I now copy and paste this 4 more times and then print the result of this code cell, you can see that we get 4, 6, 8, and 10 printed to the screen. And unsurprisingly, one more time will produce that stop iteration error. So we can see that the above generator expression didn't produce the required result immediately. Instead, it returned a generator object which only produced the items on demand. Now another useful thing I want to show you with generators is that generator expressions can be used as function arguments. In other words, they can be passed into a function as an argument to a parameter for that function. And when generator expressions are used in this way, the round parentheses can be dropped. So let's take the simple built-in function known as sum, which will sum the elements of an iterable of numbers. So if we put sum and then parentheses, we can now put a generator expression. So if I put I multiplied by 2 for I in my_list, you can see that when I run this code cell, we return 30, which is the sum of 2, 4, 6, 8, and 10. If I copy and paste this code cell and change the sum function to max, you can see that when I run this, we get 10 returned because 10 is the highest number in this iterable. Now that we've seen generators in a few examples and observed generator expressions, in the next video, I'm going to run through some of the main benefits of using generators, which will hopefully make things clearer as to when you should use them. So I'll see you in the next video.